Hi. Somebody told me if I look up out of this ice, I can see some math, so I'm gonna give it a try. Okay, I'll try this again. Now, the first thing is, on the axis provided, sketch the slope field. And we're looking at this differential equation. I'm going to list all the points, and then I'll do the slopes. I think I'll list them all with this thing off, so I'll be... Okay, so I just listed all the points down. -1, 2, -1, 1, -1, 0. And then 0, 2, 0, 1, 0, 0, 1, 2, 1, 1, 1, 0. Okay, now I'm gonna plug these in, and boy, this might be hard for my brain. If y is 2, that's 1, -1/2, so it's 1/2. Okay. If y is 1, this eliminates, and it's -1/2. Y is 0, that's -1/2 minus 1, -3/2. X is 0, that's the easiest. 2 minus 1 is 1. 1 minus 1 is 0. And 0 minus 1 is -1. And X is +1. So 2 minus 1 is 1, plus 1/2, 3/2. 1 minus 1 is 0, plus 1/2 is 1/2. And 0 minus 1 is -1, plus 1/2 is -1/2. Okay? I'm gonna check those, and I don't want you to wait, so I'm gonna pause this. Okay, crazy miracle happened. They all appear to be right. So, at the point -1, 2, the slope is 1/2, so I'm aiming for 1/2 above it. At -1, 1, the slope is -1/2, so I'm aiming right there. And at 0, I'm sorry, -1, 0, it's -3/2, so steeper. At 0, 2, slope is 1. Aiming for that. Slope is 0. Slope is -1. Aiming for this. At 1, 2, slope is 3/2, so 1/2 higher. 1/2 and -1/2. There. Okay, find the second derivative. Describe the region in the xy plane which all solution curves to the differential equation are concave up. Okay, so let's find the second derivative. D squared y dx squared. Derivative of this is 1/2. Derivative of y is dy dx. Derivative of -1 is 0. So that's 1/2 plus this, 1/2 x plus y minus 1. And that is 1/2 x plus y minus 1/2. Okay? That is the second derivative. Now we have to figure out where it is greater than 0. I'm gonna move this right here. 1/2 x plus y minus 1/2 is greater than 0. So the best way to explain it maybe is to solve for y. So we have y is greater than negative 1/2 x plus 1/2. And for all of the points greater than, so above that line, the second derivative will be positive. I want to make sure. Differential equation. For all points above, the solution curves will be concave up. Okay, there's B. Let y equals f of x be the particular solution with the initial condition 0, 1. So at this point, 0, 1. Okay. Does it have a minimum, maximum, or neither? Okay. So we do know that dy dx at the point 0, 1 is 0. So the first derivative is 0. So let's check the sign of the second derivative. D squared y dx squared at the point 0, 1 is positive 1/2. It looks like 1/2 times 0 plus 1 minus 1/2 is 1/2. So since dy dx equals 0, and the second derivative is greater than 0, that means it's positive. So we're going to have, if the first derivative is 0, there's a max or a min, right? Second derivative is positive, that means it's concave up. So it looks like we're going to find our relative minimum at, okay. So y has a relative minimum at point 0, 1. Okay? And D, the craziest one. So we have this differential equation, right? dy dx is 1/2 x plus y minus 1. For which values of the constants m and b, find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. Okay. So if y equals mx plus b is a solution to the differential equation, well, y equals mx plus b is a couple of things. See how y is mx plus b? We can plug that in. And if we take the derivative, we get m. Okay? So if this is a solution, we can set these equal to each other. So by substitution, we can replace this dy dx with m. And we can replace this mx plus b, the y with mx plus b, right? Okay, so there we have something to work with. So if these are equal, you can see this is just a constant. So this side also has to be just a constant. Okay, so let's reorganize. See how these first two terms have x's? If I factor that x out, if these are equal, then there's no x term. There's no term with x. So that means m is negative 1/2. Because the only way to get rid of that x term is to have this be 0. And the only way that's the case is if m is negative 1/2. So at m equals negative 1/2, we have negative 1/2 equals b minus 1. So b is positive 1/2. Okay, this is the answer, the solution. Find the values of m and b for which y equals mx plus b is a solution to the differential equation. So there's the answer. I couldn't do this without looking it up. And I saw the answer and I still couldn't wrap my brain around it. So I found a teacher online who could explain it in a way that I could explain it to you. And there were a couple people who just totally made stuff up. Absolutely, without a doubt, just making stuff up. And I couldn't do that. I needed to make sure I understood it. So anyway, there you have it. I told you it was a little tricky. If we look at the scoring guidelines, looks like slope fields are the same, right? I'm going to be better at showing the scoring guidelines, huh? So look, the slope fields are the same. This one, they get the same equation. I don't know if you noticed this, but the answer to B, and maybe you guys can explain this to me, but it's the same as the answer to D, right? Anyway, that's just everything above this curve is concave out, right? There. And then for C, relative minimum at 0, 1. And for D, 1 point for the value of M and 1 point for the value of B. So there you have it. And hopefully this helps you. Have it.
It sounds like you got a lot of homework to do tonight, son.